All right, I wanted to go over this problem from the quiz. First using bond energy and then heats of formation, which is for this week. So in this first one where the Lewis structure is already given for you, you're really just going in and identifying all the values for each of the different bonds here. So in this first one, you have 1, 2, 3, 4 carbon hydrogen. Sometimes it's helpful even just to say 4 carbon hydrogen, and then we'll put the values in here in just a second. So you got the 4 carbon hydrogen, I've got the carbon-carbon double bond, and then I've got the fluorine bonded to itself. In this Lewis structure, I again have 4 carbon hydrogen bonds. I also have a carbon-carbon single bond, and then I've got 2 carbon-carbon fluorine or carbon fluorines. All right. So now all I'm going to do is just go back and where those are located, the carbon hydrogen, I'm just going to put an actual value in for that. So I have 4 carbon hydrogen, 413, plus a carbon-carbon double bond, 614, a fluorine-fluorine, which is, where is that one? Right there, 155. And then on the other side, I have again those same 4 carbon hydrogens. However, remember with bond energies, this is the biggest thing. With bond energies, these values are negative, it's bonds forming. These values are positive. Remember, it takes energy to break these bonds apart. Energy is released when those bonds form. So when I write in that 413, I'm going to make it negative 413. The carbon-carbon, 348, again, negative 348. Those are bonds that are forming. And then that carbon-fluorine is negative 485. All right, so when I multiply this times this, I add those two values together, I'm going to get 2,421. Same thing over here. Multiply the 4 times this, add this, add this. This whole side is negative. I'm going to get negative 2,970. All right, so with bond energies, all I have to do is just add those two values. When I add them, I get negative 549 kilojoules per mole. All right, so with bond energies, positive values on the left, negative values on the right. Another way of saying that, takes energy to break bonds, releases energy when bonds form. All right, so now that's one way of doing it. But remember, bond energies are just averages, right? So, you know, a carbon-hydrogen bond might have that amount of energy required to break that bond in one molecule, but the composition of a different molecule, it might be slightly different. And then in a different molecule, it might be slightly different. This is just an average of all molecules that contain carbon-hydrogen bonds. In heats of formation, that is the value for that molecule. So, you know, whether it's more accurate or not, you know, these values are going to be so similar that it's really not going to matter. So we got negative 549 kilojoules per mole for this. So now let's use heats of formation to do the exact same reaction. So the nice thing with heats of formation is we're just looking at this chart and seeing that value. We don't have to draw a Lewis structure. We don't have to look at all the bonds. We just look at the chart, find that value. So in the heats of formation chart, we look at the chart, we see the molecule, and then we see that 52.30. So I'm just going to write 52.30. Another nice thing about heats of formation is anything in their natural state is just a value of 0. So this would be just fluorine gas in its natural state. Doesn't take energy to do anything with something in its natural state. So that's just a value of 0. And then this molecule is not actually in your chart. I had to look that up on the internet. Not something I knew. It wasn't in the chart. And so when I looked it up, that had a heat of formation of negative 447.94 kilojoules per mole. Now, the biggest difference between bond energies and heats of formation is here you have positive values here, negative values here, you add them together and you get your total. In heats of formation, you take them right off the chart and plug them in. So you might have negative values here as well as here. In this particular case, I have positive values and negative values, but you can have negative and you can have positive over here. The other big thing that's different between heats of formation and bond energy is here we add them together. Here I do products minus reactants. Products minus reactants. So what that would look like is my products minus my reactants. When I do that, I get negative 500.24, and again, kilojoules per mole. All right, kilojoules per mole. So now you can see this value and this value are not the same, even though we calculated the same value for the same reaction. Reason being is because this is giving us the delta H for that molecule. This is averages of those bonds. All right, so these values are very, very close. And again, we're calculating the same thing, but two different ways calculating the same thing, one slightly different. Positive, negative, add them together, take it right off the chart, products minus reactants.